and the solenoid actually just switches the pressures. Let's take a look at the other side of this thing. Probably fall apart now. Okay, there's your solenoid, where your solenoid would mount. It slides right on here, and it moves a very small valve inside here when it's energized, and it takes low pressure from here. Remember I said this was suction, and it takes high pressure from here, and it switches which way the high and low pressures go. Now they can switch it so that high pressure goes here and low pressure goes here, or switch it around. So let's take a look at what's inside it. Okay. Now, here's what we've got inside here. This slide moves back and forth. When there's a high pressure on this side from that little tube, then it pushes this way, this plunger this way, and the low pressure side allows it to come over that way. And then when it's reversed, then the pressure comes the other way. These are the seals here that seal off between here and here. Now you can see this is a little sort of a U-shaped thing here, and when it's in this position, this suction, which is right there, goes up through here and out here. When it shifts, then the suction right here to here. So you can see how that actually reverses. Now what we haven't talked about is how this discharge line here reverses. Okay, the discharge line simply goes right in, like that, and it goes to the body of the valve, the open part of the valve. You can see it's going right in there to the open part of the valve, so that when this is in this position, it can go from the discharge line here down to here, and it goes out there. Then when it shifts the other way, it goes from the discharge line here out there. Now, because these are a pilot operated valve, it's important that this thing move back and forth properly, and that these lines, and I'll turn this upside down again, that these lines are clear. If they block, any one of those blocks, the valve won't work. And problems with this valve are oftentimes, if there's a lot of garbage from a compressor replacement or something like that, then it'll block. You'll get garbage in these lines and it just won't shift, or it may shift part way. If you have one that doesn't shift, there's a couple of ways you can diagnose it. One thing, you can pull the solenoid off of here. If the solenoid is energized, like most of them are energized in cool, some are energized in heat, but if it was in cool and it hadn't shifted, if I pulled this off, then it should shift back the other way. If it does not do that, then the valve is probably bad. You can also take a permanent magnet and run it across here, and that will move the plunger back and forth. And that may do it. Now, by the way, if you do take this solenoid off, in order to test this, do not leave it hang. If you leave it hang very long, it'll burn itself up. It's not operating as it should when it's in that position, so it's going to draw too much power and burn itself up. Okay. Other things that can happen to these things are if you put too much heat when you're doing your brazing, This part here has got a little Teflon slide on the bottom of it. That can melt. And of course this is made of plastic, so it can melt. These seals here could go bad. That can also go bad if there's garbage in the system. I'm going to give you a little closer view of these things so that you have a little better idea of what's going on. Okay, so these things could get overheated when the brazing's done, and certainly when you're installing this, if you tweak these valves at all, you could damage the surface under here. Now it's pretty heavy. They may put a big copper bar in there for this to slide on, so it's hard to do that. However, this one here, this discharge one, no, you could tweak it there. If there's any damage to this tube, this thing will not slide. It just stops. It just completely stops. It may get halfway or something like that. Another diagnosis issue with these things is they'll shift part way. Instead of being all the way over, there'll be something like that. And you'll get gases moving straight from here into here. So if it goes from the discharge and ends up here, it's going to go straight back to the compressor. If it does that, it usually takes out the compressor. And then you got two problems. You come on the job for a bad compressor because it's burned up, and you end up putting the compressor in. You can't test the reversing valve until you get a pressure difference, so the compressor has to run, and you end up finding out that the reversing valve was broken, and it's what caused the compressor to fail, so you got to take it apart and do it all over again. But just remember, these things should slide all the way back and forth. They should slide smoothly. This one actually does pretty well. If it slides part way and the compressor is running when you get there, it sounds and acts just like bad valves in a compressor. It's very, very similar. The only way you can really tell is to perhaps take some temperatures across this thing and try to get temperature differences. I can't say that's going to help either. It's a real tough diagnosis between compressor valve failure and reversing valve failure, and I'm not sure every time you're going to get it. So that is the reversing valve. That's the way it slides. This moving up like that, and when it's in this position, it's moving like that. And the one that is uncovered will take the discharge and run it through there. And of course, this way it'll run it through there. Should be, depending on who you talk to, should be no more than 3 degrees difference across the valve, or 6 degrees difference. Two different brands told me the two different things. So if I went from here to here, I should have either 3 or 6 degree difference max, and here to here, same thing.